Like it or not, almost every program you'll ever write will have bugs. It happens even to the best programmers. It's human nature. We're imperfect. So given that every program you'll ever write will have bugs, the challenge becomes, how do you catch the bugs before they get to your users rather than after? One strategy is to do manual testing. Go through your app looking for any problems and then fix them. Often, this involves creating a detailed checklist of everything in your app that you want to test, or detailed testing scripts, so you can make sure to remember to check everything for your apps consistently. Manual testing definitely has its place, but it can be very time-intensive, error-prone, and tedious. So, another strategy that can really help is to add what's called unit testing into your app. Unit testing is where you write code to test your other code. The nice thing about unit testing is that you can write your test once and then you can use them forever. For example, if you write a nice set of unit tests to make sure your app is working the way you want, when a new version of iOS or Swift comes out, you can run your test to see if everything still works okay. And if something breaks, the test can help you narrow down exactly where the problem is very quickly. Unit testing works particularly well when it comes to testing data models, because as we've seen, they're often plain old Swift objects. And if they have one single responsibility, they're usually really easy to test. Best of all, Xcode makes unit testing super easy with nice built-in support. The way it works is you create one or more test cases, which you can think of as a group of related tests. It's usually good to create one test case for each chunk of your app you want to test. For example, Bullseye is just going to have one chunk we want to test, the game data model. So we'll create a single test case. In each test case, you need to provide a setup and a tear down method. The setup method does everything you need to do to get ready for your other tests. For Bullseye, we'll make an instance of our game struct and store it in a property for future use. The tear down method does the opposite. It does anything you need to do when the tests are complete. In our case, we'll simply set our game property to nil, which you can think of as nothing, indicating that we're done using the game instance. Finally, you add a method into your test case for every test that you want to run. You can put any code you want into these tests, but at some point you should call some special built-in functions that Apple has provided to test whether what actually happened matches what you expect to happen. These special built-in functions are called asserts, and these are functions you can call to test if something you expect to work in a certain way actually does in practice. There are many different types of asserts like XCT assert true, XCT assert equal, XCT assert greater than, and so on. For this episode, we're going to just use XCT assert equal. Once you've created your test, Xcode provides several different ways to run your test with a click of a button and see if your code is working the way you expect, or if there are any issues that you need to resolve. All right, now that you have a high-level idea of how this all works, let's switch to Xcode and give it a try. All right, so we want to add some unit tests to Bullseye here. And the way we do this is your project navigator, but there's different tabs up here that you can select between. And if you leave your mouse over, it'll show a little tooltip that shows you what kind of navigator this is. And we want, I believe it's the sixth one up here, that's the test navigator. And right now it should say no tests. Click the plus button to add test targets. So go ahead and click that plus button and select new unit test target. And we can leave all of this as defaults and just click finish right here. We'll switch back to the project navigator. It's created a new group for us called Bullseye Tests and Bullseye Test.Swift. And again, I like to use two spaces, so I'm going to Command A to hit everything and then Control I to indent it the way that I like it. And then what we're going to do here is, here's the setup with error, which as we discussed is where you do your initial setup for all of your tests. And our initial setup is going to be extremely simple. We just need to create an instance of our game struct. So first we're going to need a property for that. So remember, to create a property, you type in var game, which is the name of our property, colon, and then the type of the property, which is a game. And we're going to put an exclamation mark at the end. You're going to learn all about this later on in this learning path, so I'm not going to go too much into it. But long story short, this is going to be an optional variable. It may or may not be set to a value. So when Bullseye test is first created, this is going to have nothing in it. It's going to be empty, or nil is another way of saying it. After we call setup with error, it's going to have a value, which is an instance of our game. So in other words, game may be empty, like when this thing first starts up, or it may have a value. But by putting an exclamation mark at the end, we're going to say, even though it might not have a value, treat it as if the value will definitely be there, because in this case, we know setup with error is always called. But like I said, we're going to go way more into optionals later on. For now, just know we need to put an exclamation mark here. If you know that much, you'll be fine for right now. All right, so in setup with error, we need to set up this game to an instance of our game. So we're going to say game equals game in parentheses, like so. And this, by the way, and now it's giving us error, says it can't find game in the scope. That's because we have to import our bullseye code inside this file, because like bullseye is one target is what it's called. Bullseye test is a different target, so we have to import them together. And the way you do this is you put testable up front, and then you put import, and then you put in whatever your product is named, and ours is called bullseye, like so. I'm going to save the file, wait a few seconds, and then the errors will go away. And then for the teardown, we're just going to say game equals nil, which sets it back to empty. All right, for test example, we're just going to delete this code and do a little test, and we're going to call xct assert equal, and we're going to call game.points slider value, and we'll say 50. That doesn't really matter because right now it always returns 999, or it should at least. And then let me delete this other performance example because we don't need that. And this is kind of a bare bones example of a test. Now that we have our test, there's 3 ways that we can run this. First of all, we can go to product test, and what that'll do is it'll run all of your tests. You can see here it runs the app, runs the test, and you can see here that we have some green check marks over here, and in our test navigator, we see green check marks everywhere. Another way you can run test is if you want to run a specific test or a group of tests, you can click this little check mark in the gutter, and it will run that specific test or the group of tests. You can also click the buttons over here to run them from the test navigator if that's what you prefer. So we've seen an example of it working, but let me show you what happens when it doesn't work. So I'm going to go back to game.swift and say, we had a typo and it was returning 99 instead of 999. So again, I could go to product test or keyboard shortcut for that, which is Command U. And now we see red instead. And if I click on this, it'll tell you what happened wrong. So it says 99, which is what it's returning, does not equal our expectation of 999. So now we can go back to game.swift and change that to what it should be. Hit Command U again to run our tests. And this time everything succeeds. If we go back to our test navigator, we see green check marks everywhere.